Pluto is a fascinating and mysterious celestial body beyond Neptune, within the Kuiper belt. While it formerly held the title of the ninth planet in our solar system, its status was changed in 2006 when it was officially reclassified as a dwarf planet. At first, Pluto appeared out of place, as its orbit intersects with the orbits of other planets, a behavior that is unusual for a planet, but this fact has not lessened the intrigue encircling this remarkable object in space. As we gaze outward from Earth in our quest for life, Pluto stands out as an intriguing and possibly encouraging candidate. Despite being traditionally considered inhospitable to life, recent discoveries on its surface, as well as beneath its icy shell, have surpassed our expectations. Stunning images taken by the James Webb Space Telescope and the New Horizons spacecraft are changing our understanding of Pluto, revealing it to be more than just a small, distant planet. These findings have caught the attention of scientists because they do not adhere to what was once thought to be true. As we delve deeper into Pluto's hidden mysteries, new questions are raised. Approximately the size of Earth's moon, Pluto is, in actuality, only about 1,000th, or even 1/1,000,000th the size of Earth, forcing us to reevaluate Pluto's true nature and scale in the grand cosmos. The concept of a subsurface ocean beneath Pluto's frozen exterior has gained traction thanks to the discovery of extensional fractures and the absence of substantial craters in particular regions. These factors point to more recent geological activity than originally anticipated. However, the theory of a subsurface ocean is not new. It was first put forth in scientific papers in 2006, speculating on the potential for surface oceans on various celestial bodies beyond the gas giants, including Pluto. The arrival of NASA's New Horizons mission in 2015 provided data and images previously unavailable, sparking additional speculation. When the probe reached Pluto, it delivered the first close-up photographs of one of the most intriguing objects in our solar system, unveiling a surface marked by fissures, ice volcanoes, and a massive heart-shaped basin. These revelations have led some researchers to speculate that even more amazing phenomena may be concealed beneath Pluto's surface. Analyses of New Horizons pictures revealed an icy basin known as Plemons, located almost directly opposite Pluto's largest moon, Charon. While this could be a mere coincidence, the likelihood is low. Only 5% of models suggest formation without any interaction between a subsurface ocean and the Pluto surface. When Pluto's nitrogen-rich atmosphere solidified and cooled, the nitrogen gas accumulated in the basin, generating a weight that caused Pluto to shift into its present alignment. The concept of an undersea ocean has persisted over time, and photographs of Pluto's far side have strengthened this hypothesis. Strong evidence of such an ocean has been found in the form of a feature known as chaotic terrain, a landscape marked by jagged cracks and disordered plains. This terrain is located on the opposite side of Pluto from the basin known as Sputnik Planitia. Scientists have observed similar phenomena on other bodies like Mars, Mercury, and Europa, one of Jupiter's moons. On those planets and moons, asteroid or comet impacts are believed to have produced seismic waves that converged on the far side, causing a similar chaotic terrain to that found on Pluto. Alden Denton, a graduate student in planetary geology at Purdue University, simulated how an asteroid impact could send shock waves through Pluto. Results from scientific simulations suggest that such a collision would only produce the observed terrain if Pluto had a liquid ocean beneath its surface. Oliver White, a planetary scientist at the SETI Institute in California, also carried out a geologic survey of Pluto. Although he did not participate in the earlier study, he observed that while the features on Pluto's far side resemble those seen on other planets, the low resolution of the images leaves some uncertainty. Despite this, there is a general consensus among scientists that Pluto has its own distinct geological features, including a significant number of cracks on its far side, raising the possibility of a hidden ocean beneath its surface and shedding light on its potential. Theories about Pluto's origin suggest that it once had a liquid ocean that froze over due to the radioactive heat produced by decay in its rocky core. In this scenario, as the ice melted and then refroze, it would have caused the surface to wrinkle, similar to how wrinkles form on an apple left in the fridge. These wrinkles would have occurred due to the contraction of ice as it expanded after being refrozen, causing surface cracks. If this theory holds, The images from the New Horizons mission should show both older wrinkles and more recent cracks. However, the data from the mission primarily show cracks, suggesting that Pluto's surface oceans may have initially been liquid and then gradually frozen. Observations from New Horizons also revealed a massive rift operating across Pluto's near side, extending from the North Pole to the South Pole. This feature, known as the Pluto Rift, does not suggest a sudden surface transformation but rather points to the continued expansion of a frozen ocean. The presence of water on Pluto is further supported by observations of water molecules on the planet's near side, which appear to contain organic molecules. While the presence of water may seem unlikely, laboratory experiments have demonstrated that solar and cosmic radiation can produce complex organic compounds, including bases found in RNA and DNA. These findings strengthen the idea that Pluto could harbor organic molecules and potentially support life. Additionally, findings from the probe revealed a band with a reddish hue near Pluto's equator, possibly composed of organic material. This corresponds to a region receiving more solar exposure and warmer temperatures. This discovery is significant because it indicates the presence of both liquid water and organic molecules, two critical components for life. On the other hand, some UFO enthusiasts it has been implied that Pluto could harbor artificial structures, highlighting anomalies in images of the tiny planet, like a smoky trail visible on the surface. While NASA attributes these anomalies to natural processes, some people think they might be a sign that extraterrestrial life exists. In spite of the exciting discoveries about Pluto and the possibility of unsolved mysteries, it's essential to remain cautious when interpreting these results. Even though there is evidence of a subsurface ocean and organic materials, which is intriguing, much of Pluto's environment remains hostile to life. The harsh temperatures on the surface are extremely cold, averaging around -375 degrees Fahrenheit -225 degrees Celsius, far too low for liquid water to exist in its normal state. However, the possibility that a liquid of some kind could exist beneath Pluto's icy shell, kept warm from internal radioactive heat decay or tidal forces, makes Pluto's geophysical features particularly inspiring. The idea of life beyond Earth has always fascinated scientists and the public alike. With Pluto's surprising features, many are beginning to consider the possibility that this smaller planet may hold more secrets than initially thought. If Pluto's environment beneath the surface can keep organics and liquid water stable, it may not be so different from other icy moons in our solar system that show promise for microbial life. The presence of a potential ocean beneath Pluto's icy surface, combined with the finding of organic compounds, could lead to fresh discussions regarding the requirements for extreme life conditions. Pluto's place in our solar system remains a topic of debate as it continues to be studied by scientists, who are eager to learn more about its features and origins. The idea that a once distant, lifeless, and cold body could possibly contain organic substances, or even an ocean beneath its surface, challenges our preconceptions about habitability in extreme environments. It also opens up new possibilities for astrobiology's assertion that life could potentially exist in places once thought to be too inhospitable. As technology advances and more missions like New Horizons continue to supply in-depth observations, our understanding of Pluto, and the potential for life in the outer reaches of our solar system, will only deepen. Regardless of whether it's the intriguing possibility of a subsurface ocean or the detection of organic molecules, Pluto remains a focal point for future research and discovery. Its enigmatic and mysterious nature continues to captivate scientists. As we gather more data, Pluto may one day reveal even more secrets that could change the way we think about life beyond Earth. In conclusion, Pluto's transformation from a planet to a dwarf planet has not diminished its allure or its potential as a topic of scientific exploration. The discoveries made thus far, especially in relation to its organic molecules, geophysical features, and the possibility of an ocean beneath the surface, suggest that there is far more to this distant world than we once thought. As we continue to explore the far reaches of our solar system, Pluto's role in the search for life, and the science that supports it, is only just beginning to be understood. If you found this information interesting, don't forget to like, share, and subscribe for more updates on Pluto, the search for life in the cosmos, and other fascinating discoveries in the universe. Thank you for following along. I look forward to bringing you more insights into the future of Pluto. Pluto's allure for scientists and space enthusiasts stems from the many unanswered questions surrounding its existence. The dwarf planet's distance from the Sun, coupled with its unique characteristics, makes it a top candidate for future exploration. Despite its designation as a tiny planet, Pluto's features suggest an active world with a complicated and potentially dynamic history. The images and data from New Horizons have unveiled unexpected geological activity and surface features that challenge our understanding of how such a distant, small object may still bear evidence of activity. One particularly intriguing feature is Pluto's internal heat. In contrast to what was initially anticipated, the heat generated within Pluto might be enough to sustain a subsurface ocean, or at the very least allow for geological processes. This heat could come from the decay of radioactive elements deep within Pluto's interior or result from tidal flexing, gravitational interactions with Pluto's large moon, Charon, causing internal stresses. Either way, this internal warmth could be essential for keeping water liquid beneath its icy shell, potentially allowing for chemical processes that might support life in some form, even if in a radically different manner than on Earth. The existence of such an ocean raises fascinating questions regarding the opportunities for life beyond the solar system. While the cold temperatures on Pluto's surface make the idea of life as we know it seem impossible, discoveries on Earth have shown that living things can survive even in the harshest conditions. The discovery of extremophiles, organisms living in environments that are acidic, boiling hot, or under extreme pressure, has expanded our understanding of what a habitable environment can be. If Pluto's ocean is indeed liquid and contains the right chemical substances, it might contain the simplest forms of life, perhaps in a dormant or microbial state. Pluto's geology has been studied, and there is evidence of active surface processes, including cryovolcanism. This type of volcanic activity does not originate from molten rock but rather from the eruption of water, ammonia, and methane ices. This cryovolcanic activity may replenish Pluto's surface, cycling nutrients and organic materials into the subsurface ocean, a fascinating possibility suggesting that Pluto, despite its frigid temperatures and distance from the Sun, could be an ever-evolving and dynamic world. In addition to geological characteristics, mysteries are also present in Pluto's atmosphere that continue to intrigue scientists. The thin atmosphere of Pluto is primarily composed of nitrogen, with traces of methane and carbon monoxide. This atmosphere changes with the seasons due to the dwarf planet's elliptical orbit, which brings it closer to the Sun at certain times and farther away at others. This results in changes in temperature and atmospheric pressure that influence the behavior of gases and ices on Pluto's surface. The dynamic characteristics of Pluto's atmosphere, and its unusual reddish-colored equatorial band suggest that it might be a far more complex and active world than previously thought. Pluto's distant orbit and extravagant nature add additional layers of difficulty to understanding its function in the solar system. The interaction between Pluto and the Kuiper Belt, a region populated by icy bodies and dwarf planets, plays an essential role in shaping the environment around Pluto. Ancient treasures are kept in the Kuiper Belt, and studying Pluto offers a glimpse into the early conditions of the solar system. As the farthest known object in the Kuiper Belt to be visited by a spacecraft, Pluto is a critical component in comprehending the formation and evolution of planetary bodies in the outer solar system. One key aspect of Pluto's potential for supporting life is the possibility of a dynamic subsurface ocean. The discovery of organic molecules on its surface strengthens the hypothesis that Pluto might have some kind of biochemical cycle. These molecules, the basis for life on Earth, may suggest that Pluto's surface chemistry could be linked to processes that might support microbial life, even in the absence of sunlight. If liquid water is present beneath the ice and can interact with organic molecules, it's conceivable that Pluto could support forms of life, though they may be vastly different from those we are familiar with.